13 students, hello. I have some detail here in the material in section 4.3. First, we'll look at complementary events as a way to calculate the probability of the occurrence of at least one particular outcome. After we're done with that, we'll look at conditional probability. This is where we set forth a condition that has to be met before we can calculate the probability in question. All right, I'm going to share my screen and we'll get going. All right, 4.3, complements and conditional probability. We have some worked examples for you here. So I'm going to review the definitions and properties of complementary events. We're going to review then the notion of conditional probability. And as we work through this, we're going to share appropriate examples. So how does this play out? First, the review. I'm going to remind you that A and A bar indicate complementary events. You can look at the previous videos to remind yourself a bit more if you need it. We're going to use P of A bar to calculate the probability of A. So we're going to need that relationship we developed in a previous discussion. The probability of A is equal to 1 minus the probability of the complement of A, or A bar. Now, we're going to use this to find the probability of some event occurring at least once. And we note that at least once means the same as one or more, and the complement of at least one is none, or zero, nothing, nada, zip, zilps. You ever said, at least once I would like to, because you haven't done it yet? Notation. Well, A is going to be the event occurs at least once, and that has the probability P of A. A bar, the event does not occur, and that's going to have the probability of P of A bar. We're going to calculate that to calculate P of A. Now, as I note there, the probability of at least one is equal to 1 minus the probability of none. Bottom line, it's really easier to set up and calculate the probability of A bar at this point in time. So here's our example. The probability of guessing correctly on a single multiple choice exam question with 5 possible choices is a 0.2. 1 out of 5, 0.2. So when guessing on a 3-question multiple choice exam, what is the probability you're going to get at least one of those 3 questions correct? So we'll remember that when we take the notion that we just developed, the way it looks here is the probability of at least one correct question is equal to 1 minus the probability you might get them all wrong, all 3 of them. I'm going to need to define both events. Well, A is at least one correct, and A bar is at least no correct answers. And we're also going to need the probability of a wrong answer. We'll talk about that in just a moment. And the reason is this. The probability of getting none of those questions correct means you get them all wrong. So this is an example of the multiplication rule. P of W and W and W. And I'll note that the probability of A bar can be put into a straightforward multiplicative form. And I can do this because when we guess on individual questions, these are independent events. And I can multiply probabilities together directly with independent events. What I really need to determine is the probability for any one question. The probability of getting that question wrong any one time is 0.8. 4 out of 5 ways to get a question wrong in this scenario. So, probability of A bar, all wrong, you see it there. Probability of W times the probability of W times the probability of W. 0.8 times 0.8 times 0.8, or 0.8 cubed using our exponential notation. So the probability of getting at least one question correct when you guess is 1 minus 0.8 cubed. On my calculator, I'll use the caret key, get the cube going, and I'll hit enter. So 0.488, 0.488. So with a probability of 0.488 of getting at least one question correct in this exam, we're going to note that that's less than the chance of a tails on a coin flip. So there you go. Now, let's talk a little bit about conditional probability. A conditional probability of an event is a probability that we calculate and obtain with additional information about, and this is really important, a previous event. Something has happened before, and we use that information in the calculation. We have special notation, the probability of B given A. That single vertical bar looks like half of an absolute value is a logical connective. It means literally the condition that event B occurs given that A has already played out, it's already happened. You know that for a fact, it's in the bag. Now, you have a formula and you've seen it in another presentation. And I think I presented there another intuitive approach because that works much, much better. The formula can be confusing and it's really more difficult than this type of problem honestly needs to be. At least that's my feeling. So let's see how it plays out. Here's our example of conditional probability. More student surveys. So we have data on gender and preferred teaching modality. Yeah, I know currently we're all online, but that won't always be the case. And we'll look back at this video and laugh. There's our data. I've totaled it up for us, so we don't have to work with that detail. But I've got row and column and grand totals happening over there. And I'm going to define some events. Event O will be the event the student prefers an online mode of teaching. The event H, the student will prefer the hybrid mode. Event M, we've got a male student. And event F, the student is female. So let's take a look at these questions and see how the intuitive approach works. We're going to find the probability of selecting a student who prefers the online class given that the student is female. So the fact that we have a condition enables us to ignore much of the data in the table. The condition is that the student is female. I don't care about the dudes here. I'm only interested in the female students for this particular probability. So I'll note that the data of interest is what you see there in green. Now, what I'm really interested in is the number of female students who prefer online classes. I'm literally interested in those 10 out of 33. So notice my use of the notation. The probability of selecting someone who likes the online modality of classes, given they are female, is literally 10 out of 33, or 0.303. Well, the probability there of selecting a student who prefers online learning, given that the student is female, 0.303, or almost 1/3 of the students, female students, seem to prefer online learning. This is kind of subtle, so let's look at another example. This time I'm going to start with a notation. You could see either a verbal description or some tedious notation. So we're looking for the probability of M given H. What does that mean? Well, M is the probability, or I should say the event of selecting a male. H is the preference for the hybrid courses. So we're looking for the probability of selecting a male given the student prefers the hybrid modality. There's our data. Do I need it all? No. I'm only interested in the given stuff. That's the stuff that follows the word given. The hybrid data is the data of interest here. I only care about those 13 students. The rest, forget it, not for this question. How many of them are male? Well, 6 out of the 13 students are male. The probability of selecting a male, given the student prefers the hybrid modality, is 6 out of 13, or 0.462. This is where this intuition works in, being able to discard data we don't need and focus on the condition. You've had conditions in your life. You said, I will only do this if blah, 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 blah. And if blah, 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 blah doesn't happen, nothing else does. Well, here, the blah, blah is the hybrid modality. It has occurred. That's the detail of import with conditional probability. So The probability of selecting a male, given that the student prefers the hybrid course class modality, is 0.462. All right, so almost half of the hybrid students are male who prefer that modality. We have a summary. So, excuse me, we have reviewed the definitions and properties of complementary events. We reviewed the notion of conditional probability. And while we took that little journey, we saw several appropriate examples. That brings me to the end of the presentation. I hope it has been helpful. I will stop the share. And I'll thank you, ask you to do the homework problems, and do reach out. This material can be tedious. The tedium is wrapped up in the language, the vocabulary, and that sort of nuance. Thank you, and goodbye.